All right, good morning, everyone. So this morning, I like to show you how you can have a very practical approach on creating hybrid apps in Azure Stack. And hybrid is a very, if you ask people what is a hybrid app, you may hear many different things. So for the context of this presentation, hybrid application is an application that spans from Azure to Azure Stack and vice versa, or possibly between the different Azure clouds all over the world. So that's what we are talking in terms of hybrid today. And my name is Ricardo, and again, thank you so much for joining the session. So when we look at Azure, one of the key differentiators that we bring with Azure is the fact that Azure allows you to create real hybrid apps. And I say Azure because Azure Stack was born out of Azure. It's part of Azure. So with Azure Stack, what you can do is you can leverage the same architecture that you design, develop, implement, and maintain your applications on the public cloud in Azure. And you can leverage those investments and run those applications in Azure Stack. So the focus for the session today is in this very important pillar of Azure, which is hybrid. Also, Azure Stack allows you to bring Azure to the edge, allows you to bring Azure to places where the public cloud may not be an option, and allows you to extend Azure on those places as well. Over the course of this week, for those of you that had attended the other Azure Stack sessions, in total this week, I think we have 26 or 27 sessions. For those of you that had the chance to attend the sessions from Natalia, Bradley, others on my team, you saw many examples of the use cases and some very cool demos of that concept of bringing Azure to the edge. And today, in this presentation, what we will do, we'll try to create something almost from the scratch. All right. So when we look at the creation of hybrid applications, the consistency is key, right? When we look at creating Azure applications, we are looking at defining our applications using ARM templates, automating the deployment of those templates using a common set of experiences through the Azure SDK, through the CLI. So that's how we do in Azure. Guess what? That's how we do in Azure Stack as well. And the power of this is, as you have a common development model, as you have a way to use the same templates and same scripts, the endpoint, the cloud where you're going to end up deploying your application becomes a configuration setting. And why this is important is if you are incorporating Azure and Azure Stack on your CI/CD pipeline, again, you use the same set of tooling, and then as a property, you choose an endpoint that targets Azure Stack. But ARM is the same in Azure and Azure Stack. Tooling is the same, and etc. So that's a very powerful value proposition and a proposition that is really unique for Microsoft today. Now, what is tricky is that the word hybrid has many meanings, right? So let's explore a little bit of what hybrid means so we can set the context for the presentation. And again, as I mentioned earlier, I'm using the term application in a very loosely coupled fashion. An application can be a website using app services. It can be a ISVM running a given workload, right? So thinking about hybrid and based on many customer conversations myself and my team had with customers, basically working with them to identify use cases for Azure Stack. When we talk about hybrid, we can think about hybrid in some ways. You can have your application package in a set of templates with a set of automation to deploy that application, and then choose where that application is going to be deployed based on your business requirements, based on regulation. But what you do is you can get that ARM template, that complete application, and target the different clouds. So at the end of the day, hybrid can be as simple as you have the same resources that you put on the different clouds based on your business needs. And why this is valuable? You could be doing something, for example, as dev and test. You want to dev and test on-prem, and you want to go to production using the global outreach of Azure. That's one example of that incarnation of hybrid where you have your entire application where you can deploy that application on the different clouds, but it's literally the same resources. So that's one, and I would say the simplest form of hybrid. I mentioned one use case for that, dev and test. There are other use cases. For example, you may have a solution, a prepackaged solution, where you want to sell to your customers, and some of your customers rely on on-prem infrastructure with Azure Stack, and some rely with Azure. Totally fine. You can package that template and distribute to your customers, and they can deploy on their own environment. Now, things start getting interesting where you actually leverage hybrid across the clouds. And when I say clouds, keep in mind Azure has many flavors. There is the public Azure, there is government Azure, there is Azure in different geographies, and there is Azure Stack. Azure Stack is just another Azure region that you happen to manage and deploy on your own data center. So when you leverage that ability, what you can do, you can have parts of your application living in Azure Stack and parts of your application in Azure and vice versa. So, and how you do that, right? So there are a couple of ways. You can leverage the public endpoints of public Azure to be your connecting point, right? So you can have many Azure Stack instances with your application spread across those instances. And then you can use something like queues in Azure to send data back and forth between those environments. A Azure queue has a public endpoint, and that public endpoint can be consumed by any system that has connectivity to the internet. Queues are only one example. You can use other things like tables, blobs, you can use service bus, you name it. So in that, with that idea, what you do is you leverage the services in Azure that expose public endpoints, and you use that to perform connectivity. And the third way to do hybrid is when you have seamless connectivity across your Azure and Azure Stack. So for those of you that had the opportunity to watch the DevOps session with Matt McGlean and Anjay yesterday, if you had not watched that session, I highly recommend you watching the recording. They demonstrated a cloud burst scenario. And what the cloud burst scenario is, it's an application running in Azure Stack with both UI and data layer working on premises, and based on traffic, on network traffic, the front end is bursts to the cloud. It bursts to the cloud while keeping the data on-prem, and that's done by connectivity, by VNet connectivity between Azure and Azure Stack. So basically, those are the three high-level ideas of hybrid. Again, you have the same resources that you replicate across the clouds. You have resources spread across the clouds. And in that case, you can either leverage the public connectivity, or you can leverage network capabilities like VPN Express Route to connect Azure to Azure Stack. All right, so I think the best way to showcase this is to build something, right? So let's see what we can come up with. You guys have a choice: 95 slides with the Brazilian accent or a demo. Please, demo. Slides, no. No. Oh. You see, never ask a question if you don't want to go on that option. No, we'll go with demo. Let's go with the demo. All right, so where we are here, number 8. Okay, let me see what I have here. You know what? I'm going to start with a very simple example. Here's the deal. We had designed an application, and we leverage ARM templates. And we have some automation to build that application. And a new customer comes in and say, hey, now I love this application to run on my, let's say, on my disconnected Azure Stack in a ship in the middle of the sea, right? So a couple of things. Again, in this particular example, the application is a VM. Okay, so very simple. I went ahead of time and create a template that defines my application. And this template is on GitHub. Right? Pretty simple. Basically creates a VM. And by the way, this is just a fork of the simple Windows VM sample on GitHub. My idea is not going to ARM templates right now, so just to show you that indeed this template is on a public location. Great. I also set some time aside and create a very simple automation. It's hard to call this automation, but I mean, it's a script that basically performs the deployment, right? Great. So I have my template. I have a way to reproduce or deploy this template as many times I want. And I will start by deploying this template on the public cloud. And again, I'm using PowerShell. I could be using CLI. So here's the idea. I have a couple of regions in my code here, and I'm going to go into a little bit of detail. First of all, I know you are excited. You are reading my service principles. Good luck writing that down. And those service principles will be taken down after the session. So you won't be able to create resources on my subscription, unless you are very fast. All right, so as you can see, the top of my script, I basically import a module, which is the PowerShell module, to have the Azure commandlets. And then I just perform credential settings and my subscription name and things like that. And then I go into the deployment code. So here's how we are going to run this. The way we are going to run this is pretty straightforward. We are going to select, I'm going to run on debug mode, and we are going to basically select that region of code that authenticates against Azure and run that code, and then run the deployment code, and then do the same thing again for Azure Stack. And you notice that the end result will be the same. All right. So with that said, let's do that. Okay, so I need these modules here. And again, the only thing I'm doing, I'm providing different endpoints and different credentials for the different environments. So PowerShell will load the module, and after that happens, I will be able to basically connect to the endpoint and create resource groups. And notice that my deployment code will be exactly the same. So the things I do, I create for Azure Stack, I create an environment, and that environment has an endpoint. The reason why you need an endpoint is pretty simple, because the public endpoints are well known for Azure, but for Azure Stack, those endpoints will be different for your particular deployment. So we will start with Azure. So let's run this code to set my variables to connect to Azure. I will run this. And what's going to happen is the output of the screen will tell you are connected to Azure and to a given subscription. So let's, great. All right. So let me get my subscriptions here. Make sure that I have the right subscription. Yes, okay. So this is my subscription in Azure. Again, what I did, I set up a set of creds against Azure, and I authenticate against Azure. Now what I can do is, I can simply go ahead and select the deployment code and perform this deployment. Okay, so let's run this deployment here. And there is a new resource group that was created, profiles 023RG, and the deployment is going on. So let's switch to Azure. Okay, this is my Azure subscription. Here's profile 23RG that we just created. And deployment is going on. Super straightforward. You did this many times. Okay. Just to recap what we are doing, we are relying on consistency. Now the use case is we have that customer in Chile. It's a mining operation. They need to deploy the same application in the mine shaft. How that works? So let's go back to our demo machine here. And before I go ahead, I will show you the Azure Stack portal, and notice the resource groups we have here. I only have 3 resource groups, right? Okay. So let's go back to PowerShell. And I will create a new tab here. The reason I'm creating a new tab is because that process is still going on. Create a new tab is a new session. I go ahead and run the same code with one difference. What is the difference? Instead of passing the service principal and the endpoints for the public Azure, I will specify the service principal and the endpoints for my Azure Stack environment. Great. And now I can go ahead and notice how I am executing exactly the same piece of code that we executed before. What is the difference? Get Azure RM subscription. And notice how the subscription name is different from the prior example. Why the subscription name is different is because I'm targeting my Azure Stack instance. But again, I want to highlight that besides the credentials and the endpoints, the code that I'm executing is exactly the same. Great, I'm connected, I have a subscription. So what we do now, we go ahead and perform the deployment. A new resource group was created, and the name is Profiles270RG. I know, I'm really bad at naming, I apologize. So deployment is going on. Let's refresh my resource groups. And here's Profile270RG. The resources are being created. At the end, it will be the same deployment. I will stop now. We won't wait for the deployment to finish, because honestly, this is cool, but you are expecting more. It's Thursday morning, you woke up early, and you came here. So how about this? Let's try to build a real, or not a real, a more compelling hybrid application. What is the twist I want to do here? We want to leverage the public cloud, right? We want to have a component of my application in the public cloud doing something, and then a part of my application will run in Azure Stack. Sounds good? And the scenario for this is one of our customers, they are a printing business, and they operate with some very large machinery for high output printing. And those machines are not connected to the internet, right? But still, they want to leverage the same applications. They want to design the same applications to run in Azure, Azure Stack. And they want to have some of those applications running on-prem because they have to interface with those printing machines. So with that idea, here's my suggestion to you guys, or actually it's the only demo, so I won't give a suggestion. This is the demo. There is something called OneDrive, right? Why don't we do this? We are in a very tight schedule, so let's see if we can leverage OneDrive for our customers to put documents in OneDrive. Those documents will be processed in the public cloud, and then the content of those documents will be sent to Azure Stack. And we need to design and develop this in 15 minutes during this session, or we all are fired. Let's try. I'm not saying that we are going to be able to run this, okay? We'll try. At least we'll try. If it doesn't run, that's okay. Okay. So why don't we do this? Azure Stack, I have a couple of resources here deployed already. And I have a function app. I love functions because, actually, I love app service. All right, I love all the services in Azure. Other services, don't be jealous. But the thing with app services is that if you are developing modern apps, if you want a serverless computing, app service is great. And app service is available in Azure Stack. So let's use functions to do the Azure Stack processing. Great. So this is the functions portal. And I already have a function here that I wrote ahead of time. And what this function does is it receives data from a queue. And then uses the SQL client to execute an insert on a given database. Okay? Super straightforward. Is a connection string. Now, a couple of things here. Look at this connection string. If I look at the server name and my database name, SQL DB1. Oops. All right, clearly you see that it's harder to zoom than actually to write code. So, all right, trust me, it's SQL DB1 here. Yeah, don't tell Mark Rusonovich, okay? All right, so I have a database here. And I just use Visual Studio. So it's just a graphical way to look at the database. Notice the database here is called SQL DB1 as well. OK? SQL VM1, SQL DB1. Great. This database is being served by a resource that was created using the Azure Stack SQL RP. So if we look at RP validation, I also have a SQL database, SQL DB1. So this was provisioned using the SQL RP in Azure Stack. Again, I'm using out-of-box resource providers that are available in Azure Stack today. App Service, the SQL RP. One thing important to mention, this is not SQL Azure, it's the SQL RP. And what I would do now is, I have that function that will read from a queue and will write data to the database. Great. That queue can be located anywhere, right? So for this example, remember, let's going back to our use case. The use case is we need to receive documents from our customers through the public internet. And then the content of these documents and the documents itself will go over some kind of pre-processing, but they will end up on machinery that are on-prem, and that's why we have Azure Stack, okay? And assume that after I write the data to SQL Server, that data will end up on the machines. Is a good assumption? I don't have a printing machine here, so that part I will skip. Great, so we took care of the on-prem part of the application. Let's see what we can do on the public part. Okay, so Microsoft Flow, I'm using my live account, so all of you have access to Flow. If you had not used it, it's pretty cool. And I have a couple of things here. I have a flow defined that says when a file is created on my OneDrive, put that message on a queue. And if I hit edit flow, basically, I specify which folder of my OneDrive I want. In this case, it would be the root. And then I put the message on a queue named demo1. Okay. And the contents of the message is like the file name and the file content. All right. I switched to my Azure account. And on my Azure account, I do have a storage account name. Oops. Not my Hotmail. You don't want to read my Hotmail. This is exactly the same account that I defined here on my flow. See, demo1. All right. And if we click on demo1, no messages. So here's what we are going to do. let me create a file. And I will save this file on my OneDrive. Okay, I just saved the file. And one thing that will be helpful for this demo is it will be to actually turn on the flow. The flow is off. So let's run it. And what's going to happen now is, after this flow runs, a message will show up on the queue. This is the public queue in Azure. Our function in Azure Stack is reading from this queue. So as soon as a message comes up here, what's going to happen is, let's switch to Azure Stack for a moment. Let me look at my function. And if we look at the function code, I want to call out a few things. During the configuration of the function, I can specify a queue that my function will be polling from. So if I look at functions .json, notice how the queue name is demo1. It's that same Azure queue that we saw before. Now there is something here which is the public queue. This is actually a variable. Connection is a variable. And I just gave a name, public queue. OK, so if I go to my function configuration, go to Overview, and Application Settings, you notice that I have a connection string for that function. So public queue is here. And then that is a connection string for that queue. Great. So now let's check if we have, here's the idea. We will see if there is any message on that queue. And then if there is a message, we will run the function. The function will consume the data, and that data will show into the SQL instance that is in Azure Stack. All right, so it seems that my flow did not run. It's on, so let's see what's going on here. Oh, yeah, it actually ran 1 minute ago. OK. So let's run my function. OK. And let's see how much data I have here on my SQL instance. 1, 2, 3, 4. OK, I have 4 records. All right. Do you guys see this? Ignite rocks. Is that the content of the file or not? Are we fired? No. Not today. Yay! All right. Guys, I know let's just recap what we did, because we did a lot of things, right? So let's recap. Again, the scenario was, some processing needs to happen on-prem. Some process needs to happen in Azure to leverage the availability of Azure all over the world. Great. What we did, we wanted to develop in one model leveraging Azure capabilities, so we focus on Azure functionality. We use functions. We use Azure queues. And basically, functions were running in Azure Stack, consuming data from a public queue where? In Azure, right? And then writing this data to some database on-prem. And just to make it easy for us to inject data from the internet, we use a OneDrive connection using Flow, which is a completely separate service, right? But the reason I wanted to show you this, and the reason I actually use Flow, was to make it very clear that hybrid is about this. Hybrid is about leveraging the entire portfolio that we have in Azure and Azure Stack and all the other Microsoft services, okay? It could be using Power Apps, you name it, all right? Great, so the processing in Azure happened using Flow, fed into an Azure queue. Azure Stack had a function, consumed the data on the Azure queue, and wrote to the database. Now, one thing that you may have not thought about it is I'm running this function in Azure Stack, but I could get the same function and run in another Azure region for another customer. So that's the idea of the consistency, right? And that's the power. Again, we design and operate the application in one way, and we can choose where to deploy. All right? Great. So this gives you an idea of hybrid. We went from like very basic, I'm deploying templates in different clouds, the same template. This is more consistency. We went to a real hybrid application using services on both clouds. Great. So let's switch back to slides, cover some other topics, and we will come back for another demo. All right. I gave the hybrid examples already, so we skipped that. Few things for you to keep in mind when you design hybrid solutions. What you saw today is the happy path, right? Of course, it's a demo. All the demo gods are against you when you are here, so if you don't choose the happy path, you are really like increasing your odds of failing. So great, what you saw, happy path. What you need to take in consideration, you need to know your environment, okay? What that means, if you develop in Azure, you are used to the portal being portalazure.com. You are used to ARM being manage Azure.com and things like that, right? So the endpoints are public. It's actually, no matter what the region is, you hit one single ARM and you are good. For Azure Stack is different because Azure Stack is running on your infrastructure. So like the portal has a different address from the Azure portal. ARM will have a different endpoint. And you have to take that in consideration. And we did that on the first demo, right? The way we did that, we had some variables on the code where we put credentials, endpoints, things like that. The other thing, resource availability, okay? So the beauty of Azure Stack is built, was born out of Azure. ARM is the same, tooling is the same. Now, resources. Resource availability is different from Azure to Azure Stack. So you have to take that in consideration. So if you are referring to a resource that doesn't exist in Azure Stack on your template, for example, your template will fail in Azure Stack, right? So you need to understand which resources are available on your environment. And the same thing for the different Azure clouds, right? Government, the clouds on the geos. Some services roll out first in some regions, so you have to take that in consideration. So, and when we talk about resource availability, there are a couple of things to take in consideration: resource type and resource version. Resource type, what is a resource type? Microsoft.compute, Microsoft.storage, Microsoft.web, goes on. So the type, the resource type, as I said, may not be available in Azure Stack. But also the version may be different. If you look at Microsoft Compute in Azure is on a newer API version 10, Microsoft Compute in Azure Stack. So when you write your template, you need to take that in consideration as well. don't assume that resources are available at the same level in the Azure clouds. You should parameterize, you should take that in consideration. The other thing is connectivity. For the examples we saw, we are relying on public endpoints, right? The queue in Azure is a public endpoint. But you may want VPN, so this way your resources span across the cloud seamlessly. So you have to take that in consideration. Depending on the hybrid application that you are creating, you need to ensure that from a connectivity perspective, you are covered. And VPN is a solution, Express Route is another solution. There are ways to do that. So know your environment, and when you design your templates and automation, take that in consideration. A good example, my deployment script was all parameterized for username, service principals, endpoints, and etc. Right? So you should do the same. Great. So not only you should know how your environment is set up, but also content, images, marketplace items, all those things, they will be different from Azure to Azure Stack. So when you design your application, if you need a specific image, you need to check if that image is available when you deploy your template. Otherwise, your deployment will fail. Content can be added on Azure Stack through many ways. A tenant can add content as any of you can add content to your subscriptions in Azure. You can create a storage account, upload a VHD, and create VMs out of those VHDs. But also what is super cool on Azure Stack, and I'm going to show you in a bit, is syndication. You know, the nice thing about Azure Stack is it's Azure, but you get to run it. You are the manager of that instance. So with all that power, you can choose from a list of curate items from the Azure Marketplace that you can syndicate to your Azure Stack instance. And then anyone deploying applications on that Azure Stack instance can leverage those images and pre-built components. So syndication is a very powerful resource that I highly recommend you to look at. And finally, Azure Quick Starts. The Azure Quick Starts in GitHub are a great source of content examples for your templates to get started. So API versions, all right? So I mentioned this, that resource types may not be available in Azure Stack, but also for a given resource type, there may be a difference in API versions. So this is a list of the latest API versions in Azure Stack. And what is very important to keep in mind is Azure is all self-described. So through the tooling, you can inquire Azure and Azure Stack for content, for VM sizes, for API versions. So this information is available on a programmatic way. Why this is important? When you are writing your templates, again, you need to pay attention to be using resources that exist in Azure Stack, but also on the right API versions. Now, you are going to say, Ricardo, you know what? I have a hard time remember what is a given API version for Azure. Now what you are saying is that I need to keep this matrix of dates in my mind to choose the right API versions. Isn't there a better way to do that? So we recently introduced the concept of API profiles. And API profiles is a development aid to make it easy for you to author your templates and also have the right libraries for the tooling, PowerShell, CLI. So API profiles are available at the tooling level, PowerShell and CLI. It's actually currently available. It's rolled out in ARM across Azure, and it's coming soon to the SDKs and to Visual Studio with the development experience, the IntelliSense supporting API profiles. So why this is important is instead of you having to remember the specific API versions that you can use with Azure Stack, you can simply go on the top of your template and say API profile equals something. And then you simply remove the API versions property on each resource, and you infer the API version from the profile version. Now, there is a catch here. API profiles is not a translator in the sense that, let's say that you are using the profile that is compatible with Azure Stack, which is 2017-0309. And then on Microsoft.compute, you are creating a VM. If you reference something that is not available in Azure Stack, like a managed disk, that's not part of that profile, and the verification of the template will fail. So even with profiles, you will still need to know which properties to use. But the beauty of profiles is for each resource is one last thing you need to remember in terms of API version. And when the IntelliSense experience come to the development tools, that experience will be much easier, right? Because again, you put a profile tag in the top of your template, and we infer everything from you. Same thing with PowerShell and CLI. When you use PowerShell and CLI, you select which profile to use, and the commandlets that will be loaded are only the commandlets that support the resources on a given set of API versions. I'll show a demo of API profiles, and that will make clear. From a PowerShell perspective, API profiles is implemented by the Azure RM Bootstrapper, and that's available on the PowerShell gallery. So if you download the latest PowerShell modules today for Azure, you already have profiles available. So the last thing is, not the last thing of this section is identity. Service principal. I highly recommend, if you are not using service principal, I'm not going to ask who uses service principal or who puts plain passwords on the script files. I won't ask that. But if you're still doing that, look into service principals. Very useful for you to simplify the management of secrets on your scripts. And better yet, if you end up using Key Vault as well. All right, so with that said, let's take a quick look on a few things here. Let me switch my screen. Okay, that demo is over, so all right. So I mentioned that you have to know your environment. First thing, to know your environment. ARM, the gatekeeper of Azure, has an endpoint that retrieves environment information. So if you want to know about the capabilities of a given ARM instance, the first thing you have to know is which endpoints to connect to. With that said, there is a very easy way to do that. You can simply do a web request on the on the ARM endpoint, and this will work against Azure or Azure Stack or any of the Azure instances. And if we look at this output, there is some very important pieces of information here. What this output tells me is what is my authentication endpoint. In this case, in this environment, I'm using ADFS, so Azure Stack is deployed against an ADFS instance. So the login endpoint is loginwindows.net. And then the ARM resource ID from this particular ARM instance. So with that information, what you can do is you can do a get Azure RM environment. And let's take a look at get Azure RM environment. So if you look at the output of get Azure RM environment, we have we have all the public Azure clouds with all the endpoints. In this example, I'm showing Azure US Government. But then, as I mentioned, for Azure Stack, your endpoints are private. So the way you specify those endpoints is you create a new Azure RM environment that you can name anything you want. And then you provide all the resource URIs that were retrieved from the ARM endpoint. So that's why that call to the ARM endpoint is important. And after you do that, then you can do login Azure RM and get Azure RM subscription and all the other commands that I show in the demo before. But before you come to this point here, you need to know which environment you are targeting. Okay, we know the environment. How do we inquire this environment for capabilities? So I will specify the location here of my Azure Stack environment. And if I want to know all the resource providers that are available in this environment, what I do is I do a get Azure RM resource provider. And what get Azure RM resource provider does? All the resource types and all the versions. So this is the truth, right? What is being reported here is what the environment is capable of. Great. So get Azure RM resource provider. Now VMs. If I want to know which VM sizes I have, get Azure RM VM size. And it will retrieve all the VM sizes that are supported on this environment. And finally, if I want to take a sneak peek of everything that is available in terms of images and offers in my environment, I do a get Azure RM image publisher. And here all are the images I have available on this environment. So that's how you self-describe the environment. Now I show PowerShell, but I also mention CLI. So I have a couple of snippets here. CLI 2.0 is totally compatible with Azure Stack. So let's take a look at what it looks like. So the first step is to define the endpoints. So I define a Azure environment with the same endpoints that we had retrieved from the ARM endpoint. And after that, I just go ahead and perform the login. And you see it's the same CLI experience that you are used to against Azure, same thing. And then I just select the profile. Again, profile support in CLI. And finally, I can go ahead and do an AZ VM list. and it will retrieve all the VMs on this environment. Okay, similar experience, PowerShell, CLI, Portal. Talking about Portal, let's take a look at a couple of deployments here. Do you guys remember the deployment we did on the first demo? We execute 2 deployments, one against Azure and one against Azure Stack. Here's the deployment in Azure Stack. It has succeeded, and it has the same resources as in Azure. Now, interesting, what I want to point out to you is this is the template that we use for those deployments. Look at something very interesting. I'm going to do a search here and search for API version. Is there any match on API version? No. And if we look at compute, look at the definition of this VM. I'm missing an API version parameter. But still, the deployment has succeeded because I show you on the portal that the deployment succeed. Why the deployment succeed? Because the API profile tag. Okay? So that's what API profiles in ARM templates look like. All right, so this was a quick walkthrough on how to discover your environment, what is the experience with CLI profiles. Let's see what we have here on these slides. So I talked about this already for ARM templates, the importance of using dynamic endpoints, parameterize everything, be flexible with images, also scale, right? You have to take in consideration VM sizes and things like that, if those VM sizes are available or not. So usually the way you handle this is through parameterization of all these properties. Try to use parameter files when possible. Authenticate with service principal. Do leverage the tooling, right? VS has a great story with Azure Stack. VSTS and TFS also have a great story there. So leverage tooling as most as you can, and use the tools that we make available on the Azure Stack tools repository. Because we have scripts to make it easy to connect to Azure Stack, to define your environment, and so on. Great. So a few things for you to avoid. Avoid hard-coded things. And I know that this is kind of, it's a basic advice. Sometimes for the sake of time, we just we hard-code things for that quick. It's just a quick change, and the quick change lives forever. Don't assume that resources or content exists. And of course, don't use services that are not available. All these concerns can be addressed by, again, templates and scripts. So talking about content, I like to talk a little bit about marketplace and why marketplace is important for content. So the reason marketplace is important is we make it easy for you to syndicate content between Azure and Azure Stack. So if we look at the ecosystem of Azure, we support many workloads that are available in Azure today. Some of those workloads are syndicated to the marketplace. Some of those workloads can be gathered and deployed through templates. Instead of recreating everything, leverage the marketplace in both Azure and Azure Stack, and also make sure that you leverage the content existing on GitHub. So with that said, what I like to do is I like to switch back to a demo and show you what does it mean to take a complex framework and make this complex framework to run across the clouds and show you what a SI or any company developing solutions for Azure and Azure Stack could leverage the consistency on their favor. So for this demo, we are going to switch to my laptop. Okay, and let's take a look at what that means. Okay, so Cloud Foundry is a very common type of workload in Azure. Several customers use Cloud Foundry in Azure, and we have many customers planning to use that in Azure Stack. And that is a GitHub project that allows you to deploy open source Cloud Foundry, and is part of the Azure Stack Quick Start templates. The great news is that particular template deploys in both Azure and Azure Stack without any change. So if we go back to PowerShell here, I went ahead of time and deployed a Cloud Foundry instance in my Azure Stack environment based on the template that I'm highlighting here. And just for reference, I'll bring this up on the browser. And I won't go into the details, but basically what this template does is it deploys several VMs and use custom script extensions to set up a dev box. And that dev box is where you deploy BOSH, which is an open source deployment framework. And on top of BOSH, you deploy Cloud Foundry. Great. So the end result of this template here, which is publicly available, and again, this template can be deployed on both Azure or Azure Stack, is that you will have a open source Cloud Foundry deployment. And that's what I'm showing here on this resource group. So all the resources you are seeing were created by that template. And the end result of this is a VM where you have all the infrastructure to go ahead and deploy Cloud Foundry. And on top of Cloud Foundry, you can put your workloads. So this is the open source. And what you are seeing here is exactly the same thing you have in Azure. Now, one example of having those applications, those complex applications running in Azure and Azure Stack is Pivotal. So Pivotal Cloud Foundry offers several other functionality on top of the open source Cloud Foundry. And what I'm going to show you is PCF deployed in Azure Stack. And for those of you that ever try to do that in Azure, you see that it's exactly the same end result. And why? And I will go into the details on how this was done and why this is important. Great. So for that, let's take a look at our Azure Stack portal. I have another resource group here, the PCF RG resource group. And I have several resources More specifically, this particular deployment has 145 items between VMs and networks and security groups, all those things. And this is a complete Cloud Foundry deployment inside my Azure Stack instance. The way this deployment was performed was through Ops Manager. And again, the same experience that you have in Azure for deployment of Cloud Foundry, you have in Azure Stack as well. So in this particular instance, I have Cloud Foundry plus a service broker, a MySQL service broker. And if we look at the configuration of this deployment, we will be able to see all the resources that comprises all the VMs and the status of the VMs all in a single panel. One of the key differences, instead of me having to mess up with the open source version, the configuration files, and etc., I have a more user-friendly interface to manage that environment. And why this is important? This is exactly the same code that runs in Azure, but is running in Azure Stack. And how pivotal we're able to do this is using those basic concepts that I highlight for you during the beginning of the session. You know, same templates, same SDKs, and all those things allow them to bring PCF to Azure Stack pretty quickly. Now, for the end user is, this particular deployment is running in Azure Stack, but again, it behaves exactly as in Azure. So, you know, here I have Apps Manager, which is the, oh, I need the creds, good. So let's get the creds here. Apps Manager is the graphical UI to manage your Cloud Foundry deployment. So let me get the creds here. I was not expecting this. Now you see my password, all right. But this is not on the internet, so don't even try, okay? You need to access my Azure Stack environment first. And Apps Manager will give me a graphical interface to manage that deployment. And again, in terms of consistency, if I'm a Cloud Foundry developer and I want to push an application, I will do that exactly as I do in Azure or any other environment. So here I have the command line. So let's bring my cheat sheet here pretty quickly. OK, so let's see. Of course, you were not expecting I was going to remind every single command, right? OK, so I'm logging on with the client. And you know, there is a project on Git for a series of Cloud Foundry samples, so I'm going to clone that. And again, I'm not using like Cloud Foundry samples for Azure Stack. This is like what is available for Azure and any other Cloud Foundry deployment. Let me clone this repo. And I would do CF sample. And then I would do a CF push. So it will push the application up to Cloud Foundry. And then what we are going to see soon is that application up and running. And again, the reason I'm showing you this is one of the things I'm very proud of being on the Azure organization is we make sure that whatever your code is, it will run well in Azure. If it's Windows, Linux, .NET, Python, Ruby, we don't care. We just make it sure that we will run very well. And same thing with Azure Stack, because at the end of the day, Azure Stack was born out of Azure. So you can see I have an app now here. I can do CF apps. And let's grab the URL for this app. launch the browser, load this app on the browser. Here's the, it's a very simple app that just retrieves a state about the environment it's running on. And what I can do is, I can go ahead and manage this application. You see that now that application shows up here. And you know what? I'm going to scale this app. I'm going to scale down to 256 megs of memory. Let me do a scale here. Go back on the app. Notice how the memory limit was 512, right? Now it is 256, so this is running live on my Azure Stack environment. So this just gives you a concrete example of how you can get a very complex environment. And Cloud Foundry, a vanilla deployment of Cloud Foundry is 20 plus VMs. Typical customer will run in numbers larger than that. And on top of that, you have a management framework like this, which is built on open source Ruby and other tools. The only way someone can get this and move to another platform quickly is through the consistency. And the consistency with Azure is one of the biggest value props of Azure Stack, and that's what makes me proud to come to work every day. Personally, I work on enablement of those kind of workloads in Azure Stack, and I think the power of developing, designing in one single model and then targeting the cloud as you need through business requirements or any other requirement is very powerful. So with this demo, I conclude the session. Just a quick recap. We look at consistency, then we look at really extending an app between Azure and Azure Stack. We look at the development aspects, CLI, PowerShell, ARM templates. We look at profiles. And then the last thing we saw was a very complex framework that runs either in Azure or Azure Stack in the same manner, allows the same experience, and this is only possible due to how consistent Azure Stack is comparing to Azure. So with that said, I'd like to thank you for staying. I really appreciate. We do have a booth on the south side of the convention center. If you had not dropped by the booth, please do. Again, thank you so much. I will be here for a little while if you have additional questions. If you don't, enjoy the rest of the event. Have a great rest of the week, and please do fill the eval. All right? Thank you so much, guys.